Hello and welcome to Algebra 2 Lesson 13. In this video, we're going to learn about solving absolute value equations. So for most of you in an Algebra 2 course, this is a new topic. Most Algebra 1 courses do not go into this. It's considered a little bit advanced, but some of you might have seen it before. The main thing here is just to have a fundamental understanding of absolute value. Everything else we're going to do is very, very easy. So I want to start with just a brief review. Talk about things that we learned a long time ago and you might have forgotten. So the absolute value of a number is simply the distance between that number and 0 on the number line. I want you to remember that absolute value is either 0 or it's a positive value. It's never going to be negative because, again, it represents a distance. It's kind of like if I get in a car and I want to drive somewhere. I can drive 0 miles or I can drive some positive amount, but I cannot go a negative amount. Right? And I don't want to hear the joke where you're going to get in your car and go backwards. Okay, that's not going to work. But I have some examples here, and just two brief examples. Here's a number line, and let's say we want the absolute value of -3. And again, these bars here denote we want to take the absolute value of what's inside. So what is the absolute value of -3? Well, I find -3 on the number line, that's here, and I just travel to 0. How many units would I go? Well, I would go 1, 2, 3 units, and I'd end up at 0. And it doesn't matter what direction I go in, it's how far I need to travel. So my absolute value there would be 3. As another example, if I wanted the absolute value of 1, well, I'm coming from a different direction here, but I'm just traveling 1 unit to 0. So the absolute value of 1 is 1. Basically, I know that all of you remember that the absolute value of a number, if it's positive, is just the number. The absolute value of a number, if it's negative, is just the opposite of it, right? Just make it positive. So if I went through a few and said, what is the absolute value of, let's say, 6? Well, it's a positive number, so it's just the number. And I can kind of erase this and look at the number line and say, okay, well, the absolute value of 6, I can find that by just going from 6 to 0. And it's just what? It's 1, 2, 3, 4, 5, and finally 6 units traveled to 0. Okay, that's why the absolute value of 6 is 6. And the same thing would be true if I went from -6 to 0. From here to 0 is also 6 units. It's 1, 2, 3, 4, 5, and finally 6. So the absolute value of -6, I would just make it positive, and it's 6. So that leads me to my next point here. And that point is that opposites, or we call them negatives or additive inverses, whatever you want to refer to them as, are numbers that have the same absolute value. Okay, the same absolute value. Very important you understand that for this lesson. Now, I want to show you a couple of examples here, and you could come up with as many as you wanted to, but something like 3 and -3. If I take the absolute value of 3, it's equal to 3. If I take the absolute value of -3, it's equal to 3. So 3 and -3 are opposites, and they have the same absolute value. And again, you can show that on the number line. You can go up here and say, okay, well, this is 3, this is -3, and each is 3 units away from 0. This is 1, 2, 3 units away from 0. And this is 1, 2, 3 units away from 0 as well. And again, it doesn't matter which direction you're going in. You're just counting how far away you are from 0. It'd be kind of like if I was north and I traveled 500 miles to a location, or if I was south and I traveled 500 miles to a location, it wouldn't matter where I came from. It's just a matter of it's 500 miles to get there. Okay, so that's the concept of absolute value. So these I don't have to show graphically. I think we get it at this point. We know 5 and -5. If I take the absolute value of 5, I'd get 5. If I take the absolute value of -5, I would get 5 as well. -4 and 4. If I take the absolute value of -4, I get 4. If I take the absolute value of 4, I get 4. So anytime you have opposites, the absolute value is the same. Now, let me go to the first example that you're going to see in your textbook or that you're going to come across in class. So you'll get something simple like this. The absolute value of x equals 6. So the question you have to ask yourself before you read anything, before you talk to anybody, just thinking on your own, what could I replace x with to get a true statement? Well, think about it. I want this to be some number that when I take the absolute value of it, gives me 6. Again, there are 2 numbers that have the same absolute value of 6. There's 6 and there's -6 because each is 1, 2, 3, 4, 5, 6 units away from 0 on that number line. This one, the same thing. 1, 2, 3, 4, 5. 6 units away from 0 on the number line. So in this particular case, x could be equal to what? It could be 6, or x could be also negative 6. If I plug in a 6 there, I take the absolute value, I get 6. If I plug in a negative 6 there, I take the absolute value, I also get 6. As another example, let's say I had the absolute value of x is equal to 4. Again, what could x be here? Well, there's two possibilities. It could be 4, or it could be negative 4, because each would have an absolute value of 4, right? So it could be x could be 4, or x could be negative 4. Again, plug in a 4 here, absolute value of 4 is 4. Plug in a negative 4 here, absolute value of negative 4 is 4 as well. And again, you can just show yourself this on the number line. This is 1, 2, 3, 4 units away from 0. And this is 1, 2, 3, 4 units away from 0 as well. So obviously that's the easiest scenario you're going to come across, but you use the same concept when you get into the harder ones. To solve an absolute value equation, we isolate the absolute value part on one side. We then set up a compound equation with OR. Okay, remember OR is telling you that either solution is going to work. So let's look at an example. So we have the absolute value of 6n plus 10 is equal to 64. So what we need to do, again, if this is isolated for us, we can say that 6n plus 10, this is inside of absolute value bars, can be equal to positive 64. Let me put a plus out there for emphasis. Or it could also be equal to the negative of 64. So 6n plus 10 could be equal to negative 64. And you might say, well, I don't know, that doesn't make much sense. We go back to the last example where we had the absolute value of x was equal to 4. Well, this is x could be equal to 4, or x could be equal to negative 4. It's the same principle here, it's just a little bit more advanced. And remember, I could plug in a 4 here, take the absolute value, I get 4. I could plug in a negative 4 here, take the absolute value, I get 4. Both of these would work. What I am saying here is I've got to solve for n. And I want a value for n that when I plug it in here, okay, I'm going to multiply it by 6. I'm going to add 10. The result I'm saying could be 64, positive 64, or it could be negative 64. It makes no difference because the absolute value operation will make it positive, right? If it's positive, it stays positive. If it's negative, it's going to become positive. So I don't care if I get 64 or negative 64 because either way, I'm going to get a solution to the equation. So let's go ahead and solve each one of these. And we're going to plug both of them in, and I'm going to prove to you that it works either way. So for this one, I'm going to start out by subtracting 10 away from each side. And this will cancel. I'll have 6n is equal to 64 minus 10 is 54. I will divide both sides by 6 so that n is by itself. So this will cancel with this, and I'll have n is equal to 54 divided by 6 is 9. So that's one solution. Then we have our OR, so we have another scenario. So we're going to subtract 10 away from each side over here as well. That will cancel. I'll have 6n is equal to negative 64 minus 10 is negative 74. If I divide both sides by 6 here, this will cancel with this, and I'll have n is equal to, so negative 74 over 6, I can reduce this. I know it's going to be negative. 74 is divisible by 2. 74 divided by 2 is 37. And 6 divided by 2 is 3. So there's my other solution. So I'm going to put OR here. And let me erase this part, and I'm going to show you that they each work. I'm also going to write this in solution set notation. Again, we've got to get more used to doing that. So in solution set notation, remember, I create some set brackets. And inside those brackets, I'm going to put my solutions as the elements. So I have negative 37 thirds, comma, the other element is 9. That's my other solution. So I want to check these two, and I want to show you what happens when we plug them in. Again, n is equal to 9, or n is equal to negative 37 thirds. So the first one, n equals 9. So what happens when I plug in a 9 for n? So you have 6 times 9 plus 10, and then we take the absolute value of this, and it should equal 64. Well, 6 times 9 is 54. 54 plus 10 is 64. So you get the absolute value of positive 64, which of course is going to equal 64. So the left and the right side here are going to be equal. So that's our first scenario. That's kind of the easy one to understand. The second scenario is the one where it kind of takes a little bit of thought into absolute value to understand. So for this one, let me kind of back this up a little bit because I'm dealing with a fraction here, so it'll be a little messier. So I have 6 times negative 37 over 3. That's what I'm plugging in for n. Then plus 10, and I want the absolute value of this guy, and it should equal 64. So I know that this will cancel with this and give me a 2. 2 times negative 37, as we know, is negative 74. So this would be the absolute value of negative 74 plus 10, and this should equal 64. Negative 74 plus 10 is negative 64. So this would be the absolute value of negative 64 is equal to 64. Now, again, when I take the absolute value of negative 64, it's going to make it positive. So the two sides are going to be equal because of the absolute value operation. So that's why we end up with two solutions here. So this, we kind of scroll down a little bit, turns out to be 64 equals 64. And so this is good to go. So what we can say here is that this solution is correct as well. And again, it's an important insight to understand why these two solutions work. Again, when I plugged in a 9 here, I got positive 64. Took the absolute value, I got 64 equals 64. When I plugged in a negative 37 over 3 in for n, I got negative 64. Took the absolute value of that, I got positive 64. So it might be still a little bit confusing, but we're going to work a lot of examples here. So let's go to the next one. So for the next one, it's a similar setup. We have the absolute value of 10x plus 10, and this is equal to 20. So again, what I'm saying is that what's inside the absolute value operation, which is 10x plus 10, well, that could be equal to 20. But also, I'm going to put or. This could also be equal to negative 20. So 10x plus 10 could be equal to negative 20. You set up these two scenarios. You set up a compound equation with or. Again, because if I find something for x that when I plug it in makes this whole thing equal to 20, I'm good, right? The absolute value of 20 would be 20. Additionally, if I find something that I plug in for x and it makes this whole thing equal to negative 20, I'm also good because the absolute value operation will make that negative 20 positive 20. So again, you've got to think about those two different scenarios. Let's go ahead and check this out. So we would subtract 10 away from each side of the equation here. That would cancel. I'd have 10x is equal to 20 minus 10 is 10. Divide both sides by 10, and we would get x is equal to 1. Over here, let's subtract 10 away from each side of the equation. That cancels. I'll have 10x is equal to negative 30. Divide both sides by 10, and we'll get x is equal to negative 3. So what we find here is that x equals 1 or x equals negative 3. In solution set notation, I would say negative 3 and 1 are my elements, right? They're my two solutions. Let me erase this real quick. I'm not going to check all of these, but I will check a few just to kind of pound the point home that this value inside can end up being 20 or negative 20, and you're going to end up with the same value on each side, right, once you take the absolute value. So if I start out by plugging in a 1 for x, the obvious scenario, 10 times 1 is 10, so I'd have 10 plus 10, and I take the absolute value of that, and that should be 20. And of course, 10 plus 10 is 20. So the absolute value of 20 is 20. You get 20 equals 20, so of course we are good to go there. The other one, again, that's the one that confuses people, and that's the one that people just don't think about. So if I plug in a negative 3 there, I would have the absolute value of 10 times negative 3 plus 10. This should equal 20. 10 times negative 3 is negative 30. So I would have the absolute value of negative 30 plus 10, which is negative 20, and this should equal 20. Again, the absolute value operation here is what allows us to have a negative 20. When I take the absolute value of negative 20, I get positive 20, okay? So this becomes 20, and it equals 20. So 20 equals 20, that's true. So this works out as a solution as well. So here, x can be 1, or equally valid, x could be negative 3. Two solutions for this equation. All right, so now that we've gotten through the easier ones, let's look at a tougher one. Now, what do I do in this scenario? I have negative 5 minus 4, and this is multiplication because it's hanging out outside. So times the absolute value of negative 8 plus k, this is equal to negative 17. Well, what we want to do is we want to isolate the absolute value operation. So we want to get this by itself, and we can do that because we happen to be very good at algebra at this point. So the first thing I'm going to do is I'm going to add 5 to each side of the equation. So this would cancel. What I'm left with on the left, I'd have negative 4 times, I'm going to put a multiplication symbol there so it's obvious, the absolute value of negative 8 plus k, and this is equal to negative 17 plus 5, which is negative 12. Now, again, this is multiplication. I want this thing by itself. So if I have something multiplying something else and I want to isolate it, I'm going to use division. Just like if I had 6x equals 30, I want to isolate this, I divide both sides by 6. Right? Simple. It's the same thing. If I want to isolate this, I divide both sides by negative 4, because that's what I want to go away. So this is left the absolute value of negative 8 plus k. And then on the right side, negative 12 divided by negative 4 is simply 3. So now we have it in a format that we saw in the last two examples. It's all that you need to do. Just get the absolute value operation isolated on one side. You want a number on the other. And again, you set up your compound equation. So this guy inside the absolute value bars can be equal to this or the opposite of that. So it is negative 8 plus k is equal to 3, or negative 8 plus k, again, could be equal to negative 3. If this was 3, it's good. If this was negative 3, the absolute value operation makes it good as well, okay? So to solve these, very, very simple equation, add 8 to each side over here. You're going to get that k is equal to 11. And over here, add 8 to each side, and you're going to get that k is equal to 5. So I've got my solution of k equals 11, and then my other solution of k equals 5. So let's erase everything. We're going to check that. So again, we have that k equals 11, or k equals 5. And again, using the solution set notation, 5, 11. That's going to be my two elements. So let's start by just plugging in a 5. So I plug in a 5 there. So I'd have negative 5 minus 4. Let me make that negative a little better. And then this is times the absolute value of negative 8 plus 5. And this equals negative 17. So negative 8 plus 5 is going to give me a value of negative 3. So this would be negative 3. Remember, this is multiplication. So down here, I'd have negative 5 minus 4 times, again, the absolute value operation makes this positive 3. This should equal negative 17. So I do multiplication before I do anything else. You can think about this as plus negative to make it easy. Negative 4 times 3 is negative 12. So you'd have negative 5 plus, again, this is negative 12, and this should equal negative 17, and it does. Negative 5 plus negative 12 is negative 17. So our solution of k equals 5 is correct. All right, for the other one, we want to try k equals 11. So you'd have negative 5 minus 4, again, times the absolute value of negative 8 plus 11. This equals negative 17. So negative 8 plus 11 is 3. So let me replace this with 3. And again, the absolute value of 3 is 3. So I'd have negative 5. I'm going to write this as plus negative 4 times 3 equals negative 17. And it's the same thing because the absolute value operation, whether it's 3 or negative 3, puts out a positive 3. So either way, I got the same thing here. The rest of it's the same. Negative 4 times 3 is negative 12. You get negative 5 plus negative 12 equals negative 17. This is negative 17 equals negative 17. So this checks out as well. So k here can be 11, or equally valid, k here can also be equal to 5. All right, so the next three problems I'm going to give you are going to be trap questions that you're going to come across. Your teacher, your textbook, whoever you get information from, your tutor, maybe just this video, somebody's going to give you a problem that's going to look something like what you're going to see in the next three problems. So a common trap question would be something like this. The absolute value of x is equal to negative 7. Again, why is that a trap question? Go back to a number line, and I'll bring one to the screen there. Tell me what number you have that has a distance from 0 of -7. It doesn't exist. You might say, oh, well, 7. No, it doesn't work that way. 7 has a distance of 7 units away from 0, right? If I counted, it'd be 1, 2, 3, 4, 5, 6, 7. The answer here is there is no such x, because as I told you in the very first part of this video, absolute value is a distance. A distance is either 0 or it's positive. I get in my car. I want to go somewhere. I either start the car and it doesn't work and I don't go anywhere and I go, damn, I'm not going anywhere today, or I go some positive amount. I do not go negative. Again, not with the joke about backing up. That doesn't work. So for this particular type of problem, there is no solution. There is no solution. Okay? You can also put the symbol for the null or empty set, right? Because the solution set contains no elements. And you just want to remember that whatever is inside the absolute value bars, you can just say the absolute value of x, for example. This is always greater than or equal to 0. It can be 0 or positive. It cannot be negative. So this is not going to work. All right, so let's look at an example. So you see something like this. It looks nice and normal. You're like, okay, I'm ready to get my solution. So you have -7 times the absolute value of 2x plus 2 minus 4 equals 52. Okay, so I'm going to start by trying to what? Isolate this. I want to isolate this. So I'm going to add 4 to each side. That's going to give me -7 times the absolute value of 2x plus 2. This would cancel. It'd be equal to 52 plus 4 is 56. Now, if I want to isolate this, again, if I'm isolating this, and this is being multiplied by that, well, I want to divide both sides by this, so I can get rid of it. So this would cancel with this, and over here, 56 divided by -7 is -8. So I now have the absolute value of 2x plus 2 is equal to -8. Is there a problem? Yes, there is. I know this is a little bit more complex than me just saying the absolute value of x is equal to -7. That's obvious. This one right here, somebody might start thinking, yeah, I can make that work. I can go 2x plus 2 equals -8, or 2x plus 2 equals 8. I see students do this all the time. It's not going to work. Stop and think about it. I can find an x here that's going to give me a value of -8 when I evaluate. So let's go ahead and do that, and I'm going to show you what happens. Let's subtract 2 away from each side of the equation, and that will cancel. You'll have 2x is equal to -10. Divide both sides by 2. You get x equals -5. Okay, so let's say I plug in a -5 here. What's going to happen? Let me just erase this so we have a little room to work. We don't even need it anymore. So 2 times -5 is -10. So I have the absolute value of -10 plus 2 is equal to -8. Now finish this up. -10 plus 2 is -8. And you might say, oh, I nailed it now. I got -8 on this side, -8 on this side. Hold on. It's inside of the absolute value operation, so it's not going to work. Once I take the absolute value of this, it's +8. +8 does not equal -8, so this doesn't work. You can't do it that way, okay? If you isolate your absolute value operation and it ends up being equal to a negative, stop. There is no solution, okay? So when we come across a scenario like this, and we go through all the work and we isolate it and we say, okay, the absolute value of 2x plus 2 is equal to -8, we stop. We say, nope, they're not going to get me on this trap question, and there's no solution. Okay? Put the symbol for the null or empty set. Because again, no matter what you plug in for x there, once you take the absolute value of it, it's going to be 0 or positive. It will never, ever, ever be negative. So you can't possibly get a solution. All right, so another special case is when you've isolated your absolute value operation and it's equal to 0. So here I have the absolute value of x plus 3 equals 0. Well, in this case, you can get a solution, but there's only one possibility. Because 0 is its own opposite, right? Its absolute value is 0. It's 0 units away from itself by definition. If I look at a number line, just for reference, here's 0. How many units is it away from itself? 0. If I get on Google Maps and I say, how far am I away from where I'm standing? I'm 0 units away. So it's a distance. It's 0 units away from itself. So in this case, I would just say, Well, if the absolute value of x plus 3 equals 0, then I just solve one equation. X plus 3 equals 0. I don't need to go x plus 3 equals negative 0. I see that on tests all the time too. Please don't do that. Okay, there's no such thing as negative 0. Negative 0 is just 0. So then I would just subtract 3 away from each side here, and I would get that x is equal to negative 3. And that makes sense because if I plug in a negative 3 there, negative 3 plus 3 is 0. The absolute value of 0 is 0. And we could just write this, again, using solution set notation, put a negative 3 inside of some set braces. All right, so let's look at an example here. So we have negative 6 times the absolute value of 3y plus 1 minus 2 is equal to negative 2. Again, let me isolate my absolute value operation. And so to do that, I'm going to add 2 to each side. So that will cancel. And I'll have negative 6 times the absolute value of 3y plus 1. And this is equal to negative 2 plus 2 is 0. Now, I want this by itself. If negative 6 is multiplying that, divide both sides by negative 6 to get rid of it. Okay, this is going to cancel with this. And I'll have the absolute value of 3y plus 1 is equal to 0 over negative 6 is 0. I have the scenario I just told you about. The absolute value operation is isolated, and it's equal to 0. So there's only one possibility. It can only be true that 3y plus 1 equals 0. Again, please don't say or 3y plus 1 equals negative 0. The negative or opposite of 0 is just 0. So you have one situation here to solve, and I just subtract 1 away from each side. I'll get 3y equals negative 1. Divide both sides by 3, and I get y equals negative 1/3. Okay, so let's erase everything. Okay, so y equals negative 1/3. In solution set notation, I put a negative 1/3 inside of some set braces. And again, if you want to check this, pause the video, plug in a negative 1/3 here, and see that you get a true statement. You should get negative 2 equals negative 2. And in fact, let's just go ahead and do it. So I'll have negative 6 times the absolute value of 3 times negative 1/3 plus 1, and this is minus 2 equals negative 2. So 3 times negative 1/3, this will cancel with this and give me negative 1. Negative 1 plus 1 is 0. So this right here would end up being 0. So I'd have negative 6 times, remember this is multiplication because it's hanging out outside. I'd have negative 6 times 0, then minus 2 equals negative 2. 0 times anything is 0, so this is gone. This is 0. I'll just have negative 2 equals negative 2. So yes, this solution is correct. Y equals negative 1/3. All right, so kind of the last special case scenario you're going to deal with is where you have two absolute value expressions that are equal to each other. So before we kind of get into that, I want to remind you of one thing that you might have overlooked. So two expressions or two numbers can only have the same absolute value if they are equal. So that's one scenario. 2 has the same absolute value as 2. Those two numbers are the same. They're equal. Negative 2 has the same absolute value as negative 2. Again, those two are the same. They're equal. Negative 19 and negative 19 have the same absolute value. Or the other scenarios, they're opposites, like we've been talking about. So 14 and negative 14, 12 and negative 12, 210 and negative 210. So they have the same absolute value because they're opposites. Or again, numbers or expressions that are the same or equal also have the same absolute value. So those are your only two scenarios. So when we encounter something like this, the absolute value of 5x minus 3 is equal to the absolute value of 2x plus 2. So there's two possibilities. One is that 5x minus 3 is equal to or is the same as 2x plus 2. So this would kind of be like saying, okay, the absolute value of 3 equals the absolute value of 3. They're the same. Same number, so of course the absolute value would be the same. We're saying that these are the same. So that's kind of your first scenario. Then you have a second scenario where you make one of these into its opposite. So for example, I have 5x minus 3 is equal to, if I want the opposite of this, I just put parentheses around it and I put a negative out in front. So the negative of, or the opposite of, the whole expression. So 2x plus 2. The common mistake with this, a lot of people see it in their textbook and they forget about how it was modeled. They'll just put a negative out in front. This is only making the 2x negative. It's not doing anything with this. The whole thing, we've got to apply this negative there. So make sure you use parentheses there so you apply the negative to each term. Okay, very important. So this here is the scenario where, let's say we have the absolute value of 3 is equal to the absolute value of -3. They're opposites, so they're still going to have the same absolute value. So we've covered each scenario. Again, two expressions can have the same absolute value if they're equal or if they're negatives. Here they're equal, here they're negatives. So we start out by solving this guy. We add 3 to each side. That's going to cancel. And we subtract 2x away from each side. That's going to cancel. 5x minus 2x is 3x, and this is equal to 2 plus 3 is 5. Divide both sides by 3, and you get x is equal to 5/3. The other guy over here, let's distribute the negative to each term. Okay, just think about it as a phantom -1 out there. So we have or, we will have 5x minus 3 is equal to -2x minus 2. Just distributed the negative. Let me add 3 to each side. And let me add 2x to each side. So this will cancel and this will cancel. 5x plus 2x is 7x, and this is equal to -2 plus 3 is 1. Divide both sides by 7, and we get that x is equal to 1/7. So my solution set here contains two elements. We'll have 1/7 and 5/3. And let's go ahead and check this one because I want you to see that it works. So again, we have that x is equal to 1/7 or x is equal to 5/3. And if I start out by plugging in a 1/7 for x here and here, let's see what we get. So we'd have the absolute value of, we have 5 times 1/7 minus 3. This should be equal to the absolute value of 2 times 1/7 plus 2. So 5 times 1/7 is 5/7. Let me just replace this in here. And this is minus 3. So I've got to get a common denominator going. Multiply 3 by 7 over 7. I'll have 21 over 7. And this ends up being -16 over 7. Which, of course, once I take the absolute value of, would be 16 over 7. And then over here, I have 2 times 1/7 plus 2. If I do 2 times 1/7, that's 2/7. That's easy enough. And again, I've got to get a common denominator going. So let's multiply 2 times 7 over 7. 2 times 7 would be 14. So this would be 14 over 7. 2 plus 14 would be 16. So this is 16/7. And of course, if I take the absolute value of that, that's just 16/7. So I get 16/7 equals 16/7. So we can see that the solution x equals 1/7 does work. Right? We get the same value on the left and the right side. And again, remember, this solution came from when we set them as negatives of each other. I took this one and I set it equal to the negative of this one. So you have a negative of this one, but when we take the absolute value, it's the same value. So again, that's why it works out. Now for the next part, let's check the other guy. We're going to end up with the same value in each side in the absolute value operation because we did this equals this without making one of them the negative of the other. So for the other one, we have the absolute value of 5 times 5/3 minus 3. Then this equals the absolute value of 2 times 5/3 plus 2. So of course, 5 times 5/3, 5 times 5 is 25, so this would be 25/3. So to get a common denominator, multiply this by 3 over 3, you would end up with 9/3. So 25 minus 9 is 16, so this would be 16/3. So it'd be 16/3. Over here, 2 times 5 is 10. You'd have 10/3. So 10/3. And over here, to get a common denominator, multiply this by 3 over 3. 2 times 3 is 6, you'd have 6/3. And if you add 10 plus 6, you get 16. Over the common denominator of 3, you'd have 16/3. So the absolute value of 16/3 is equal to the absolute value of 16/3. Of course, that's true. You get 16/3 equals 16/3. So yes, this one works out as well. This solution came from us just saying 5x minus 3 equals 2x plus 2. So of course, when we got down to this stage of checking it, it's the same value in here as in here, okay? It's the same value that we're taking the absolute value of in each case. Again, when we checked this one, we had the negatives of each other because we said 5x minus 3 is equal to the negative of this expression, 2x plus 2. And so that's why we ended up with this equals the negative of this. But again, when we take the absolute value, it makes everything positive. So that's how we got a true statement in that case. All right, let's take a look at one more. So if the absolute value of 3x minus 9 is equal to the absolute value of 12x plus 15. So again, I want one scenario where they're equal to each other. So 3x minus 9 is simply equal to 12x plus 15. Or I want another scenario where they're opposites. So I can make this guy 3x minus 9. I can make it negative. So the negative of that whole thing, again, make sure you use parentheses, is equal to, this would stay positive. So 12x plus 15, right? I won't do anything to that. It just stays as it is. So this is just straight, removing the absolute value bars. This one, I'm making one into its opposite so that we follow the rule to say if two numbers or two expressions have the same absolute value, they're equal to each other or they're negatives. That's what we have. They're equal, they're negatives. Okay, let's solve each one. So we add 9 to each side over here, and we subtract 12x from each side. And so this cancels and this cancels. 3x minus 12x is negative 9x, and this equals 15 plus 9 is 24. We divide each side by negative 9, and this will cancel. We'll get x is equal to 24 over negative 9 is going to be negative. Each is divisible by 3, so this would be negative 8 over 3, so negative 8/3. Then we have or. All right, let's deal with this scenario now. So the first thing I'm going to do is just apply the negative. So negative times 3x is negative 3x, and then negative times negative 9 would be positive 9. And this equals 12x plus 15. Now what I'm going to do is subtract 9 from each side of the equation. And I'm also going to subtract 12x away from each side of the equation. So what's going to happen is this will cancel and this will cancel. Negative 3x minus 12x is negative 15x. And this equals 15 minus 9, which is 6. Now, all I need to do is divide both sides by negative 15. This cancels with this, and I've got x is equal to, each is divisible by 3. I know it's negative. 6 divided by 3 is 2. 15 divided by 3 is 5. So this is negative 2/5. So x equals negative 8/3 or x equals negative 2/5. So let's write that up here. So again, x equals negative 2/5 or x equals negative 8/3. And again, in solution set notation, we can write this as negative 8/3, comma, negative 2/5 inside of some set braces. And I'm not going to check this. I'm going to leave this up to you to check. Again, you're going to plug in each value for each occurrence of x. So I'd plug in negative 8/3 here and here. I would evaluate and make sure I get the same value on the left and the right. And I'm going to do the same thing with negative 2/5. What you're going to find is that in one scenario, you'll have the same value inside the absolute value operation on each side. That makes sense because for one of these, we just said remove the absolute value bars. 3x minus 9 is equal to 12x plus 15. So that's what we expect there. In the other scenario, we said the opposite of this was equal to this. So in that scenario, when you check, you're going to end up with opposites inside of the absolute value operation. When you take the absolute value, you'll end up with the same value on each side.